Hi everyone, in this video I walk you through my approach to solving a machine learning problem, predicting the power output of a power plant based on environmental conditions. This is a supervised learning problem because we are working with labeled data. That is, the dataset includes actual power output values we can learn from. So our goal is to build a regression model that can accurately predict energy output. Since we are dealing with continuous values, a suitable output metric is mean absolute error, or MAE. MAE is easy to interpret. It tells us the average absolute difference between our model's prediction and the actual output, essentially how far off we are on average. From the dataset description, ambient temperature appears to be the most influential feature. That's because the power plant's energy output is directly affected by the surrounding air temperature. We'll compare multiple models using the same algorithm but different feature combination. Feature selection is the most accessible way to explore different model configurations within Excel. So when choosing an algorithm, I consider accuracy, interpretability, and computational cost. Because the dataset is small and interpretability is important, I chose a linear regression model using the least squares method. It's simple, fast, and easy to understand, ideal for working in Excel. To evaluate model performance, I manually split the data into 90% training and 10% for testing. Then the training data was further divided into 80% for training and 20% for validation. Since I'm using Excel, I performed these splits manually to create separate training, validation, and test sets. As you can see on my screen, so here on the data for each set, and on each tab, I have different models. Now, as you can see on my screen, I built 4 different models in Excel, each using a different combination of input features. I use Excel's data analysis toolpack to perform linear regression and calculated MAE on the validation set for each model. After comparing results, Model 1 delivers the best performance on the validation set. It had the lowest MAE, so I selected it as the final model. And then evaluated Model 1 on the test sets using MAE, and here is the result. Final MAE is 3.66. This is a very acceptable level of error, especially considering this plant's capacity is typically above 400 megawatts. That is an acceptable level based on industry standard. To wrap up, we identified a simple supervised regression problem. We use Excel to build and compare models with different feature sets. We chose a model with the lowest validation MAE and validated the final models on a separate test set. Thanks for watching.